Hey, good morning, good afternoon, good evening, everyone. I hope you are well, staying safe, healthy. On behalf of All India Oracle Users Group, we would like to welcome you to Oracle Groundbreaker Yatra online webinar series. Oracle Groundbreaker Yatra 2020 is a 14 days non-stop learning and networking event. This virtual event is one of the largest Oracle Users Group webinar series with 125 hours of education. As you can see the statistics from this slide, speakers are presenting from 25 plus countries. One of the highlights of this year Yatra is 60 plus Oracle Ace and Java champions are joining and presenting. This is normally happens at Oracle Open World. So please pass this information to your connections. We are on day 15. Still, we have many number of hours to learning and networking. Registrations are still open. It takes 2 minutes to complete. Today, you can see this is today's agenda. Every day we are hosting eight sessions starting from 10 a.m. to 10 p.m. with the proper breaks. Please check our website for accurate timings. We just finished a demo or a HOL type of session with Sanjay Goyal. It started at 9 o'clock, so please always check our website. And today's is a second session of the day. Brief introduction of AOUG. AOG is one of the largest Oracle users group in APAC region. This is the platform created for Oracle community to learn, network, and share about Oracle. History of Yatra. We normally host our annual conference called Sangam in Bangalore and Hyderabad, but it was challenging for other users located in other cities. To support, we started taking a bunch of key speakers to major cities in India. Started with 5 cities in 2013, and last year we covered 10 cities in 15 days. And this year we were planning to do 15 cities in 20 days. But we all know due to global pandemic, we are hosting virtual online webinar. Good part of this webinar is we are able to bring most of Oracle gurus across the globe. So do not miss this unique opportunity to learn and expand your network. This is very important slide. I'll keep this for a few seconds. Why it is important, show your support to All India Oracle Users Group. You have no idea about our efforts. This is a voluntary organization, and we are putting so much efforts to run this webinar series. So you can thank a volunteer group, and also convey your simple thanks to speakers. They're coming in different time zones and spending valuable time and presenting with us. To encourage them, you need to say some few words or thanks to speakers via Twitter. Also for yourself, right? This is the only way you can make more connections virtually. And currently you can't see other participants, right? And by doing this, we were able to bring more speakers across the globe. Not only that, you can also get connected to the speakers, right? So if you want such events to be continued, so we need your support to bring that, promotion. Okay, with that, so today we have Christopher Jones, Senior Principal Product Manager from Oracle. He's basically working with the Oracle database data access team primarily on APIs for scripting languages, including Node.js, Python, PHP, and ODPI C libraries for Oracle database driver writers. I think we'll take some introduction from Christopher to explain what is driver and all the stuff. But also, interesting thing is he's also released a popular book, The Underground PHP and Oracle Manual. I think that's really a great book. If you're not seen, so please, you can. I think maybe we can ask Christopher where we can buy or maybe we can access. And also, it's very important, right? So tweet about this session, and you can see Twitter ID. And also, we have another great speaker from his team, Avinash Nandakumar. Is a software developer and works for Oracle Access, specialized in pooling technologies and contributors in CX underscore Oracle driver for Python. So you can see both the speakers in the video. Maybe you can say hi to them. And yeah, you can't say because you're not switched on the video, but at least the speakers say hi. And also you can see the hobbies and interests. So, and he's from Australia, so it's very nearest to us. So with that, I'm Christopher or Avinash, you can take access and share your screen. And warm welcome, Christopher and Avinash.
Thank you very much. Just while Avinash is sharing screen, you mentioned that the PHP book, that's actually a free PDF downloadable from the oracle.com website. You can Google it pretty easily. A lot of the content obviously is PHP based, but if you look at the CX Oracle driver documentation for Python, you'll find very similar documentation there as we expand and improve that documentation for you Python users. So welcome everyone, thank you for joining. Today we are going to show you how to write efficient Python applications that use Oracle database. My name, as mentioned, is Christopher Jones. I am a product manager in the Oracle Data Access team. So I look after quite a number of APIs and interfaces. We were just talking about that before. We're not quite sure what to call them nowadays. Do we call them drivers? Do we call them APIs? Do we call them interfaces, modules? I think you know what you mean. You know what we mean. It's the API that you call within Python. I also look after the Oracle Instant Client packaging that some of you may know and love and enjoy. My colleague Avinash Nandakumar is a very key developer in our data access area, and he's actually going to give you most of today's presentation. But before he gets into detail, let me give you an overview of our interface, highlight some of the new features in the latest, greatest release, because I know some of you have already started using that. So Avinash just kind of jumped ahead with the slides there. That's the data stack of the area that I mostly deal with personally. You can see I deal with a lot of the scripting languages, but also down at the bottom right, I also deal with C APIs, Oracle Call Interface, and ODBCs and things like that. So I've quite a big hat to wear on my head. And today, obviously, we're going to speak about Python CX Oracle. So that is sits on top of this ODPI-C API that was mentioned. And underneath all of those is the C stack, the proprietary C stack, and I'll explain why that's important later. Avinash, do you want to just move on? Thank you. So let's talk about CX Oracle itself. Let's not waste any time. It is the interface that provides access to Oracle database from your Python applications. It lets you access the database, it lets you run SQL statements and PL SQL statements. It even lets you now use the new NoSQL style document storage, SODA, S-O-D-A, Simple Oracle Document Access you might know about. It lets you do other fun things such as subscribe to database messages. Avinash is actually going to show you some of these a little later. So CX Oracle has been around for a long time, lots of functionality. Actually, the most widely used of our open source APIs, gets about 1 million downloads a month. So it's very, very widely used. So if we have a look at the stack there, just for people who are not familiar with this, it's you can see that CX Oracle is going to execute your application code in the app.py file. Any of those CX Oracle function calls are ultimately passed down to our C stack and then across the network to the Oracle database, which is handling all the heavy work for you. So interfaces like CX Oracle are what we call thick client stacks. They all rely on those Oracle client libraries. So these libraries actually do all the heavy work. They provide the important features such as connection pooling, efficient data transfers, compression, network encryption, high availability features. They're very widely used, very efficient, and are well tested and are common across all of our stack. So I have one slide on installation. There's a lot in the documentation, but just for those who don't kind of know where we are, first, obviously you need Python installed. So CX Oracle 8, latest and greatest, works with Python 3.5 or later. The previous release, CX Oracle 7, can also install on Python 2. Then once you have that, you just use this pip module, install CX Oracle API. Depending on your configuration, you might find these ---- proxy options handy, or the ---- user is very handy if you don't have access to write into the Python installation directories. For example, if Python was installed by a system user. Next, you need Oracle client libraries. I mentioned those before. They come separately. They're not part of Python or the CX Oracle driver. Typically, you can just download these from oracle.com. There's a free download called Instant Client. Just download, unzip that, set your library path, and then everything works nicely. So that's the one slide overview. Check the Oracle installation documentation for precise steps. So just moving on, got just a couple of slides before I hand over to Avinash. I know some of you are already using CX Oracle, so let me just tell you about these latest, greatest features. So the first on the next slide is that the character set, default character set has changed to UTF-8. So this character set affects how characters are transported converted backwards and forwards between Oracle database and Python. For varchar 2s, for lobs, there's a data mapping which goes on between the character set that the database is running and the character set you tell your application to run in. So importantly, with this latest version, the character set in the NLS lang environment variable is no longer used. Now, generally that's not going to be an issue because the default is going to be UTF-8 and your applications generally are going to run perfectly fine. If you do want it to change, then you actually just set the character set using the existing encoding and the N encoding, which is the national character set for the N varchars. Just set that when you're creating a connection or a connection pool. So the next thing is that in CX Oracle 8, we're trying to make things easier for you so you don't need to go and fiddle around with system settings and then setting environment variables. So we've got this new init Oracle client function. It's useful on Windows and Mac, can be used on Linux, but not as useful. So for example, on Windows, as I've got here, I could call this as I've shown on the screen. I wouldn't need to change the Oracle path, sorry, the OS path environment variable to include those Oracle client libraries, the thick client libraries. I could just pass in here this libdir parameter. So I can do kind of runtime install. You can do wgets now from OTN, download those instant client libraries, run your application without needing to actually go back into the system control panels there on Windows. Notice the R before that double quote, quote C, that's a raw string, and that's because we have the backslashes there on Windows. So the final thing that I want to talk about on the next slide is a little bit about performance. So this was also something we tweaked in CX Oracle 8 for you. So we have a new prefetch rows parameter that augments the existing array size setting. And these help you tune round trips. So Avinash has a couple of examples later, but round trips are the trips backwards and forwards across the network to Oracle database. And the database has to wake up and do work and then send you data back. So round trips can affect scalability because not as many users can access the database if the database is talking to you. And obviously there's network overhead as well. So by increasing these two settings, prefetch rows and array size, you can tell the database to send more rows back in every single trip across the database. And then they get stored in these caches, which I've got in that little diagram, PF and AF, and then are accessible to the application. So increasing these parameters reduce the round trips because more data gets sent across the network, but they take more memory in Python application. They do not affect how many rows actually return to the application or when they returned. They're just internal cache sizes used for buffering to make transfer efficient. Of course, when you fetch a lot of rows, you might need to do more than one round trip to the database, but you can still tune for optimal behavior. So that's it from me. Over to Avinash, who's going to share a lot of great tips to help you make efficient applications. I'll come back later to help answer questions at the end. And if we have time, maybe even show some demos.
Thank you, Chris, for giving the brief overview. So I'm Avinash. I work as a developer in Oracle client interface. And I have myself contributed to this particular driver, and I will let you see what all we have to offer in CX Oracle to make your life very good if you use Oracle on Python. So let's start with the basic thing, how to connect to the database. After you install CX Oracle, you need to provide CX Oracle the location where your DB is present. So this is typically done by providing a connect string. So this is how a connect string would typically look like. You would pass the username, password, host name, and the service name. The important thing to note is that password need not always be sent in clear text. You could make use of wallet-based authentication or OS-based authentication such as Kerberos, among others. So Oracle has a lot of options to connect to the database. You could also pass in the port numbers or other subdomain names. In some cases, you would also want to pass in some parameters to this connection string. If you find the service name and connection string too intimidating, you should go for configuring the TNS names.ora file. So it is one of the most configurable method to connect to the database. So in this particular file, you will have an alias name, let's say inst1, and the service name, which would be something which looks like this, the mapping. So instead of putting the entire service string, you could directly put in this alias name, right? So it makes your life quite easy. Oracle also provides this make DSN call, which creates the service name out of the port numbers and host name, among others. So all of these are available in Oracle documentation in great detail, and I would recommend all of you to even go through the documentation if you have some problem, or you can raise a question with us as well. Moving on, Oracle allows you different ways in which you can connect to the database. So the typical example is a standalone connection. So in case of a standalone connection, your client is connected to the database in a one-on-one channel, right? So when the connection is created on the server, one process is spawned, and that this process will be there through to service you throughout your connection duration. The important thing I would like to note is that connection creation and termination is a very costly activity. So if you have multiple clients, you could as well share these connections, instead of always creating a new connection up front. So for this purpose, Oracle has several pooling technologies. So one of the pooling technology is the connection pool, which is like a client-side connection pooling technology, and the other is a database resident connection pool, which is of course on the database tier. So pooling is a good solution if you have apps which have a burst of DB activity. Typically, mid-tiers would have, in case of most applications, would have a brief DB activity. They would probably want to query a particular result set or just insert a particular record and move on. So in such cases, pooling is definitely one of the good solutions. I'll talk about it in more detail in my next few slides. So this is a dedicated connection, which I was talking about. This is the default way in which you connect to the database. The important thing here to note is that when a connection is created, server process gets spawned here, and this will service you. So if you have too many connections, equal number of servers get spawned here. So I will explain why this might not be a very great idea if you are going short on server resources. An interesting thing to note here is the with clause here. So the with ensures, it's a Python paradigm, that this connection which has been created here gets closed automatically when you exit the scope. If you don't use with, you should actually do a connection close when you exit. Otherwise, you would end up leaking the connections. So let's move on to the pooling solutions, which I was mentioning. So the first solution is the connection pooling. So connection pooling on the client side is the best solution for you if you have connections with a short DB activity. And so you could have a few connections, and multiple clients could be reusing those connections, and you could scale up a great deal. So these connections can grow and shrink according to your parameters that you have set. So the important parameter you would like to set is that you use session pool object. And apart from the details which you had previously set on your connection object, you would set in the min, max, and increment. So min is tuned according to your average load that you're expecting. Max is set if you are expecting a peak load, which you have calculated, and increment is to scale up. In an ideal world scenario, the performance team suggests, real world performance group have done benchmarking, and they recommend that ideally the pool should be a fixed size. So you would like to keep the min max at the same value and increment as 0, and thus the pool will not change. It's a fixed size pool. The reason why this is better is because when we are starting to create connections at runtime, the pool performance will decrease a bit. So if the pool is of a fixed size, you can always service better. So it's a connection storm or something like that, you won't see any performance issues. Of course, this connection pooling can also be configured with several parameters, like you can have a no blocking kind of mode, among others. All of this is there in Oracle documentation, and you can leverage it and help make really good apps, scalable apps. So another technology of Oracle is database resident connection pooling. So here you see that connections can be pooled across mid-tiers. You see there's a mid-tier 1 and mid-tier 2, and they can share these connections. So why you should use a database connection pool is, as I was telling earlier, if you have many connections to this, there will be too many server threads, server processes spawned here. And if you are running out of memory, you should use this solution. Also for scalability, I'll show you in the next slide how this is going to really help. So again, if you have a lot of resources on your server, you should always go for dedicated. But DRCP does give the similar performance. The pooling, connection pooling at the server level, DRCP gives you almost the same performance with a really high level of scalability. So if you are using DRCP, you should add this pool parameter to your connection string. And if you want to distinguish between different mid-tiers, you can set this connection club. And of course, there are some ways in which you start the pool. So all this is provided in Oracle documentation. So I would like to show you the performance benefit of using DRCP. So both these stacks are of the server. So let's say there are 5,000 users who would like to connect to a database. So we do a comparison between the dedicated server versus the DRCP. So in case of dedicated server, we actually create 5,000 server processes. Whereas in the case of DRCP, we set the pool size of 100 and only spawn 100 such processes on the server. You can clearly see that in the first case, we use up a really huge amount of memory, that is 43 GB. And in case of DRCP, you are using much lesser memory, right? So you can see the amount of scalability. So you see 5,000 users have been mapped to 100 DB threads, the DB processes, and it gives almost same performance. If you are having a typical mid-tier application, which has short burst of DB activity, this can really scale up a great deal. In fact, this number 5,000 you might think is unrealistic, but we have even a benchmark to get the values as high as 20,000. So you could have 20,000 clients connected with just 100 server processes, which gives almost good performance as a dedicated connection would give you. So anyone who is using this thing should try to use DRCP and see your application scale greatly. So now I'll get you through some best practices that you use when you are using session pooling. So typically, when you acquire a connection, the application developers would set some application state, like the NLS, PL/SQL package settings, etc. But the point I would like to emphasize is that setting this is a costly activity. It requires a round trip. So if you have a dedicated connection and you do this kind of thing, for each connection, you would have to set the application state. If you use pooling, what happens is that only at the time when connections are created upfront, you actually need to set these values. So how do we do this? We do this by setting a callback, session callback. So when the session is created, we set the application state here. So this callback gets fired only when the connections are created upfront, when the pool is being initialized. After the pool is initialized, these connections are reused. So this application state is set only once in the beginning when the connection is created. To get you the numeric perspective, let's say you keep setting on each connection, right? So the pool.acquire call will require 1,000 times the set application state to be set, and of course your useful work which you will do 100. So there will be 2,000 such round trip calls. And if you set multiple states here, like there are 2-3 states which you have to set, so this number really goes up. So with this particular pooling technology, you could use along with the set callback, you could just do it almost half the number of DB calls. So using session pool has a lot of advantages. Internally, we have features like application continuity and high availability, which helps you to get a seamless transition if there are failovers on the network or on the server side. So it's always good to use pooling technologies provided by Oracle. So now we'll see how to get data from the database. So typical fetch call, Oracle provides a lot of fetch APIs. If you want to just query one record, you could go for fetch one. If you want to get the entire row set, you could use the fetch all API. The only thing to note is that when you use fetch all, you should have sufficient memory on the client. So if the batch if the row sizes are very small, it is a ideal way to get the entire memory. But typically your rows would be really large and the data would not come in one particular call. So you would like to use something called as fetch many. The fetch many does batch execution. So you have to keep calling this in a while loop and do some relevant work with the data. An important thing to note here is we set some parameters called as array size and prefetch rows. These parameters affect internal performance. Note that if you do not tune this properly, still you could get the entire result set, but it will could take a much longer time. This is because if there is not enough memory in your application, the fetch call would do a round trip to get the data from the database. So if the array size is not properly tuned, you would be doing multiple round trips within this call. And by the time you get the data, it would take a really long time. Similarly for prefetch, as Chris had mentioned earlier, these two really help increase the performance. So if you are planning to fetch a really large amount of data, you should make sure that array size and prefetch rows are set to a very large number for best performance. Again, this is a small bit of cheat info I'm providing you. Suppose you wish to fetch only 20 rows. So you would set the array size as 20 and prefetch as 21. One extra so that there is no extra round trip to detect end of fetch. So this is how ideally fetching will make it. These things help to tune your performance very much while fetching. Oracle provides support for large object types called as lobs. So it could be a huge image size or video size. So they are typically stored as lob data. So Oracle allows you to query data directly from a lob, and you could use lob.read in CX Oracle to get the data back. An interesting point to note is that lob.read is actually could take multiple round trips to fetch the data, because if the data is huge, again it would require multiple round trips. So ideally, if your lobs are of a smaller size, we recommend you to convert the lob to a character type or a string type and fetch the data. So CX Oracle provides you this interface called as output type handler. So whenever you get the object of type character lob, you convert that to a string type and fetch the data. By doing this, we really see a very large improvement in performance. So you see lobs which are around 8 kilobytes of size, and if they're fetched as strings, you get a considerable amount of performance improvement, almost double, more than double actually. So these are some of the optimizations you should be aware of, which can help you improve your performance while fetching. Again, a good example of this kind of handler is, when you're dealing with different type of formats. So Oracle stores numbers in a decimal format, whereas Python keeps the number in a floating point notation. So when you do a fetch, you would see results like these, which are more precise actually, but more user readable output would be this kind of thing. So you could cast this whenever there's a number returned, you should cast it into a decimal type and print the data. So there are many such uses in which output type handler can be set and data can be converted from one form to another. Again, CX Oracle the Oracle allows PL SQL packages, which are like application. You can actually create applications within the database. These are called as stored procedures, or PL SQL properly called as. So PL SQL allows you to even return a result set, as it's called as a cursor. So here you can see that a cursor has been outbounded and the data can be fetched here and returned. We'll see how to print this data here in the example next slide. So now I create a cursor object. I pass it in to the PL SQL procedure block. So call proc is used to call PL SQL procedures. And once that is done, we print the entire row set. So you can see the entire row set here. So this is how you can pass in ref cursors into the PL SQL block and get the result from there. Of course, Oracle likes to make the life of developers easy. So we have a feature wherein you can get back multiple result sets actually implicitly. So you can see I am creating two cursors C1, C2, and I'm returning them using this return result set. The interesting thing to note is that here, unlike the previous example, I have not passed in an outbound variable here. So it's like an implicit result, right? And this particular feature I had myself implemented in CX Oracle. So you can actually query all the result sets and print the data. So you see both the result sets have been printed here. So this is the interesting thing, that you don't need to bind the data in this thing. So implicit results is a good feature if you have multiple cursor sets being returned. Next part is how to put data into the database. So everyone, typically what happens among many application developers is they actually get the input data and directly concatenate it into the SQL and execute the SQL. This is really very dangerous, if you might be aware. It could cause something called as a SQL injection attack. What happens is malicious SQL is sometimes inserted into the data, which could cause a change of the statement itself, and it could result in unintended database activity, which could even compromise your system. So binding is a very important way to reduce this kind of SQL injection. Also, binding has additional performance benefits. Internally, we don't need to pass the data if you have bound the data at the time of creating. So I'm trying to add here a number and a string into the this particular bind variables. So I could use different ways of inserting it. Here there's a case where I use it list. Here there's a tuple. These are all Python native types, or a name key value dictionary, or even as a keyword arguments in a function call. So there are different ways in which you can insert the data, bind the data, and leverage these features. Sometimes in real life applications, you would want to insert a really lot of data, large amount of data. So you could always insert the data one at a time by calling insert many times, right? Execute many times, but that would not be a very good method, because Oracle provides something called as execute many, wherein you do a batch execute. The advantage of batch execute is that you reduce the round trips considerably. Suppose there are 10 data that you want to insert. So if you do it one at a time, you will have to do 10 network calls. Whereas here you just do one network call, right? So it's really a great performance improver. So we have a slide here which actually shows the benefit, which is expected actually, because the network latency is very less in this particular case. So for inserting 10,000 rows, you see the amount of time which is being used here. It's very paltry compared to what you would do if you keep inserting data one at a time. So while doing batch execution, you may be worried, what if the data is wrong, right? In this particular case, you see there are duplicate keys, or in this case, you see that this particular value is not present in the parent table. So we will have errors when we are inserting this data. So batch errors is a particular feature which we have developed so that you can go ahead and insert the correct data, and whichever data is wrong, you get back in this particular call, and you can see at what offset what error has happened. Example, here we can see the unique constraint violation at offset 2 among others. So it's a really cool features. Important thing to note is that whatever data has been correctly inserted into the table, you would want to explicitly commit it or roll back it, right? And so this particular thing you have to remember when you use this feature, what to do with data which has already been inserted. So moving on to Oracle supports objects. You can create objects and insert it into the database table. So it's really good for ORM kind of models, among others. So let's say a typical object like a spatial object which Oracle provides. Oracle also provides some default object type for spatial calculations like SDO geometry. Python also allows spatial objects which are used for three-dimensional mathematics, among others. It gives a lot of functions. So along with Oracle, you can use Python in a very good way to handle these kind of object types. So let's see how the schema of this particular object. This object has a number type and two arrays within it. So we will see how to insert this particular object type into the Oracle database through CX Oracle. So the key thing is we create the get type to get the schema of that particular object. But for all the sub elements which are there in that particular object, we again use the get type here. So we have the schema of all the types here. Then we instantiate using new object. We insert the values. So here it's a number, which is a very straightforward insertion. In this case, we need to create the sub object. So we again call the new object. We then insert the array into it. Similarly for the next member. And then finally, we insert this object, bind this object and insert it into the database. The important point to note here is that get type is actually a call which goes to the server. It's a round trip. So you would, if you are dealing with too many objects upfront, you should do once a get type and store the schema somewhere and then reuse it multiple times rather than creating the instance once. So we have different types of other objects also which you can insert, like the PL SQL objects. So it's a similar code which you can do. So you basically do get you get the type of the object and then you insert the value. It's a similar thing, similar for PL SQL records. So I guess these slides will be available to all of you. So the using get type and new object methods, which I had mentioned earlier, you could insert any kind of object data into the database. So moving on to a very interesting feature which Oracle provides to developers, the advanced queuing. So if there are multiple applications and you want to synchronize them over the web or any other way, you could use a queuing as one of the solutions. So Oracle provides queuing support and we have a large list of actual features. If you are trying to do agile development, you could use this queuing paradigm. So Oracle has multiple features which makes it unique to Oracle. Like you could subscribe multiple listeners. You could modify message once it has been sent and rebroadcast. We have multiple language support as well on these queues. And again, what makes Oracle queue very unique is it's a database integrated message queuing, which allows you security and persistence. So let's see how to create a queue. So this is how you create a queue table. So this is the syntax. We create a queue of the type raw. So basically the raw kind of binary data will be inserted into the queue. And this is when you create the queue. And this particular block you have to execute once and the queue is ready to go. You could start sending messages and start receiving messages. So let's see how you use that in CX Oracle. You create the queue object here by giving the queue name. And then you add the data one at a time. So this is the data. So I send the data one at a time. So there are some message properties which you can set. I'll come to this a bit later, but this is how you would send one data at a time. And again, if you want to send multiple data, multiple messages, you could use enqueue-many to send them at one shot. So the advantage of using enqueue-many over enqueue-one is that round trips are much lower. Similarly, for the DQ, so here we get one data at a time. So since the data is raw format, that we had encoded earlier in the message properties. So we have to decode the data using the connection encoding and print the data. And if you want to do multiple DQ-many, you need to set the number of parameters which you like, messages you like to fetch, and then you print them. So These are some of the interesting features which Oracle queue. So as you said, the example which we have given is actually very simplistic, right? But Oracle queue, if you see the documentation, it's a really huge one actually. There are a lot of features in it, and due to the paucity of time, I would go through some of the important features. Like let's say on the queue, while you enqueue the data, you would like to set the enqueue immediate. This is because by default, the message gets sent only after a commit call. So the commit call, this is because enqueue, it's called enqueue on commit. So this is to avoid race conditions and data inconsistency issues. If there is a lag between commit and data sending. But there may be some scenarios where you want to send the data immediately. You could use enqueue immediate. Similarly, on the DQ side, you may want to not block on your messaging. Suppose you are trying to read from the message queue and the queue is empty. So you would end up waiting on the dequeuing operation forever, and that could be a block in that. So you could use dequeue no wait, wherein it just checks if there is a message in the buffer. If it's not there, it just goes ahead, and you could requery it later on so that your application does not block or hang. Another important feature at the message level. So these were on the queue level. So at the message level also you can set properties such as the expiry time. Suppose you have a time-bound message which should expire in say 60 seconds. So you set this expiration parameter, and even if no one picks up the message in the 60 seconds, after the time period, it will delete the message from the queue. So these are some of the really cool features which I have enlisted, and there are much more which you can use, and it's really, you can configure your queue to a great extent. So anyone who would like to use queuing solutions could try Oracle queuing solutions. The next is continuous query notification. So in case of some data-driven applications, they would like to know if the data in a database has changed, and accordingly they would like to make changes. For example, you have different views in your system, and you would want to know if the data has changed. So in that case, you could subscribe a query notification. Whenever there is a change in any data, or a particular data has been inserted, or even if the result set of a particular query has changed. For example, in this particular case, I want to monitor this particular query. If the result set for this has changed, I would like to receive a notification. So let's say I add a record whose ID is 10, which is less than 100, I will immediately be fired the notification. But if I send the value of a data which is more than 100, say 1000, ID is equal to 1000, I insert this particular data. So in that case, the notification will not be fired. So basically, we are allowed you to configure the query notification to a great extent. The key thing to note is that this particular message parameter can even give you the row offset and other details, which will help you to identify which particular row changed, among others. So all of these you can check in Oracle data documentation. Edition-based redefinition. Sometimes, as I had mentioned earlier, Oracle allows you to create database applications on the database using PL/SQL packages. Suppose you would like to have multiple versions of your application. This is a typical scenario, like the development. Suppose you are developing a new feature, you would like to keep another edition of that, and then there will be a production edition, which is the base edition. So you could have two different editions of your application in Oracle using this edition feature. And whenever you are done with your development, you could just transition it to the next edition. And the added advantage is there is no downtime because both of the editions are active on the same database. So let me give you an example to make it more clear. Suppose you have an application and there is one particular function in that application called demo editions. So here in this case, you see that it returns edition 1. So this is the base edition. Now you want to develop a second edition. So you just change your edition to the next version of the edition, which is called demo. And then you, in this particular case, this particular package returns edition 2. So similarly, if you have a large application, the entire code can be changed actually, and it will behave in a completely different way. So both these are actually present at the same time on the database. and you are able to leverage them just by setting the addition differently, right? So how do we do it in CX Oracle? It's very straightforward. You just pass in the addition name which you want to use, and you will get the appropriate result set. So in this case, in this example, you see that in the first case you see addition 1, and in the second case addition 2. So note the same procedure I have called actually demo additions, but they're returning two different data, or they can behave in different ways. So it can really be configurable. I mean it is really useful in application development scenarios. So coming towards the almost the last particular feature which I would like to specifically speak in this particular topic, it's called SODA. The SODA is a simple Oracle document access. So people who would like to use NoSQL and Oracle, they should use SODA. So you could add JSONs into your database, and you can use query by example, which is like typical of any NoSQL database like MongoDB. So you could use the same features here. And the additional advantage of using Oracle database is that it's well managed, it's more secure, and data is persistent because they are mapped internally to RDBMS tables. Of course, this is not just a feature of CX Oracle. You can use it in all of our languages that we support. So anyone who wants to move to NoSQL on Oracle could try SODA APIs. So I'll quickly go through how useful these APIs are and how similar it looks to any other NoSQL data store. So you get the SODA database, and then you create the collection. And here you see the user name Maya is who stays in Melbourne is inserted into this particular table and collection. And then whenever we insert a particular document, we even have a metadata which is there, or the key is generated uniquely to identify that particular this thing. So you could store that key and later use it for querying, which I'll show you in the next example. So this is how we inserted data. Now I want to retrieve data. I could use the key that I had earlier got, and then I could make a call to get that particular record, right? Or I could use query by example, like a name which has character MA, and I would get the list. I could print them all. So you see Maya and Mary are outputted, and you can always do a count. So this is very much similar to any PLC, any NoSQL kind of data store languages which you might have used before. Again, for replacing data, it's a similar thing. You can query it by key and then replace it, or use regex to remove it, among others. So it's anyone who wishes to use NoSQL on Oracle is welcome to try out these APIs, and if possible transition to Oracle, because it's much more secure, persistent, and gives all the good points of the RDBMS below. So with this, I come to the end of what I had planned to discuss, what we had planned to discuss, me and Chris. So we both are happy to get this opportunity to speak. If you have any queries when you try to use CX Oracle, you should contact us in different resources. So Chris, who spoke earlier, is very active, and he's the first person to contact. And in case you would like to raise an issue, you could go to our GitHub location where the entire code is stacked and raise issues. So we are very active. We will try to ensure the earliest support to you, among others. So it's a great opportunity to have spoken today. And I would like to end this talk. And if there are any questions which you would like to raise, or problems that you're facing right now, you could shoot your questions. Thank you very much.
Hey, thank you, Avinash. Why don't I share my screen? If you unshare your screen, I'll just show a few more things in the last few minutes. I have been answering questions as we go, so I think most of the questions are already answered. So let me just share the screen. So presuming that all looks good to you, and you can actually share the screen and possibly even see me. There we go, with my San Francisco background. I worked out of Oracle's headquarters for a number of years before coming back to Australia. So I like seeing that background. But what I'm showing on the screen anyway is the standard CX Oracle homepage. It's here on GitHub. We do a lot of the work on GitHub. The source code's all in a GitHub repository, so it's open source, so you can contribute to it. You can see we're already started on our next version. Not much work has happened there since we've only just released the 8.0 last month, in the last couple of weeks. But this has all of the access to the resources that you need. And in particular, there was a question about the tutorial, and this is the tutorial online. So this runs through, you can download from GitHub all of the sample files in our sample directory tutorial. You can get hold of all of the, well, even solutions, you can get hold of all of the sample scripts, SQL scripts to set up everything on your system, and then just follow along the steps along here to look at all of the great things that we've shown today. Don't forget, we've got a lot of documentation now. So I mentioned, or was mentioned, the PHP Underground manual. This is effectively the same as that, but for Python. So you want to look at this. Lots and lots of interesting information here about executing all different models you can use, and particular things like tuning. So we've mentioned those slightly complex things about array size and prefetch rows. These are all explained here. Examples you can play along with as well. A lot of good stuff there. So I'll just run maybe a couple more minutes with a couple of demos just to run live. I can't see any other questions come up. So we've got a bit of time so I can run that. So this is that samples directory I just showed you on GitHub. This is my clone. I've done a git clone of this directory. And there's a bunch of things in here, some of which I won't run immediately. Let's have a look at bind inserts on the top of the screen. This is obviously importing the module. We need to actually get the module. Sample env basically just gives us our credentials, just so that we didn't have to modify every single script every time it ran on a different system. But we obviously get a connection, single connection, no pooling being used here. And here we're going to use that array insert, the array DML function, to actually insert all of these data values with one insert statement. So this will be one round trip across to the database, backwards and forwards, much more efficient than doing 7 round trips with 7 different executes. At the bottom, you can see we're using a sort of Pythonic way. We're doing the for row in the execute itself, and not even using a fetch one or anything like that, just printing out the data as it comes back. Let me split the screen, and in the bottom half, I'll run that. And I have Python 3 is set up with the Oracle extension module, and no surprises there. My prints have echoed back what I've inserted. So that was the basic stuff. I'm actually going to do a bit of Soda and then come back to something else which wasn't covered in the talk, which will be kind of interesting. So this is the Soda example that Avinash talked through. Kind of got this get database, pretty much a no-op, just gives a bit of a data structure. Collection, you can think of this as like creating a table. In fact, it is a table on the back end, which then you can go and query as a table if you want to do some big data analysis on the data. But you don't need to do that. You can just insert your documents. And this is effectively, this data here is just going to be inserted as JSON, as you can see here, this dict, Python dict. So, oops, let's get the spelling right. So to basic. And this was the example that Avinash showed. I think he'd customized some stuff away from my hometown Melbourne to do different names. The Australian Matilda, unofficial national anthem. But you can see that we have exp as well. So this is all a filter. You can see this is a chained operation. You can add a bunch of things on. So you've got a bunch of initial stop execution of statements after a certain amount of time because they want things not to hang, or they have a guaranteed quality of service response time back to the user. So in recent versions of Oracle, 18 onwards, we are able to support a call timeout. So this was, you came into CX Oracle at a certain time, but then you still need the Oracle libraries of a certain version as well, because that's where all of the magic happens. So you need the 18C version. And this is a client-side attribute, and it affects statements which are being executed in the database. So it doesn't affect connections. You have to actually, whoops, if you can see, you actually set it on a connection. So this doesn't affect how long it's going to take you to open a connection. It affects operations using that connection. And in fact, I haven't run this recently, so we're living dangerously. I'm not sure whether this is going to time out at some stage. I can't see, yeah, so it timed out. So my long-running operation here, which was either a sleep or a session sleep or a lock sleep, depending on which version I had, tried to run it. I ran a call proc, so that's how you call a PL SQL procedure. As a call proc, you pass the procedure name in, and then any of the arguments that you want to pass to the PL SQL procedure. That obviously ran the lock, and but because I had the timeout set for 2 seconds, the timeout occurred. So that's pretty cool. Now, I showed you that stack diagram earlier because it's important to understand all of these layers. Not everything is controllable through the CX Oracle driver itself. A lot of it is controllable through the SQLnet layer. For example, encryption. If you want to add network encryption, you do that in the SQLnet configuration. Had a question about Oracle Internet Directory. I think OID. I think that was a question. How's that configured? That is also configured through the SQLnet layer. Once that's all configured with ldap.oro kinds of files and whatever else you need, in CX Oracle, you just pass in the connect string, which is configured in those configuration files. So there's no real magic in CX Oracle for that. And this is an example. So this is a SQLnet.oro file. You notice I actually got a leading full stop there, and that's because that's in my home directory, which is one of the default locations. So in the Linux and the Unix world, the configuration files in your home directory all tend to start with a leading full stop. And you can see I've set some parameters here. There's a bunch more. You can see some in the Python doc and a huge amount more in the SQLnet doc. So these are a couple of things that you can set to sort of bound the operation of your applications. So this will mean that if a connection takes longer than a certain amount of time, if that initial connection creation is going to take a certain amount of time, 5 seconds in this case, then I just want an error to come back. I don't want to hang forever. Receive timeout is about messages, so this is actually quite long. I was just playing around with this. This is 3 minutes. So receive timeout means packages. I spoke about the round trips. It means if any round trip takes longer than 3 minutes, I'm going to kill things. Expire time is actually an interesting one. This is kind of a keep alive, and that will send a ping across the network every 2 minutes to keep the connection alive, which is useful if you've got a firewall which is terminating things. So there's a couple of high availability things there. So I've spoken to about just a couple of things there. I can see 3 more questions have come in, so let me just answer those. So there's a question about what the home page is on GitHub. So let me put that on the chat, and that was the home page for somebody who doesn't want to Google. And the URL for the demo is there. So that one's up. So that's on your chat. And if you wanted to start, there's a question there about establishing many connections. So Avinash covered this relatively early in terms of using a connection pool. You would want to open a connection pool, which you do at the start of the application. Typically, by the way, you'd use threaded. I know he didn't mention that in the slides. He didn't want to bog things down, but obviously if you've got multi-threaded application, you need to tell CX Oracle to do appropriate locking. Avinash spoke about the min, max, and the benefits of setting these to be the same, so you don't have connection storms. And here, then you could, as many times as you like, run the pool acquire. Actually, I think I have an example of that. Let me just pop that up in the last 2 or 3 minutes that we've got allocated to us. So there's a connection pool example again in this CX Oracle samples directory. And this, I'll just go full screen on this. So as you saw earlier, I'm going to create a pool, min, max 2, so the same things we saw before. And there is, forget that little version test. There are 2 methods which are going to be called, 2 procedures which can be called. And if you look at the bottom, we've got some threads starting, and one's going to call the top procedure and the other's going to call the bottom one. So both of these will get a connection from the pool and do different things, all in parallel, or as parallel as Python can be, considering it's got this whole global interpreter lock, which is always an issue in terms of parallelism. So I run that. Actually, I'm going to split the screen and we'll go back to the code so you can see the code at the top. So you can see it's got the long query it's beginning to execute. It's just being called multiple times. And then the lock is obviously just happening once at the bottom. So that's it. I think we should wrap up there with 2 minutes to spare. I would like to thank the Oracle India Oracle Users Group for organizing this, and I really appreciate your time today. So appreciate
Thank
that.
you. Thank you very much, Christopher and Avinash, for spending valuable time with us, and really very insightful session on Python and CX Oracle. I think hopefully we can host you a masterclass with more hands-on labs in upcoming months if you're available, right?
Sure.
Definitely.
Sorry, it's
Yeah,
taking me time
definitely.
because
I
I
will
answer
come.
questions, but yes, we're obviously available.
Sure.
Yes.
I think people are really appreciating in a chat. You can see, I think if you can do the Twitter, that will be great, guys. A few announcements, boring announcements. Just to hold for 2 minutes. So learn and win. I think anyway, we are closing tomorrow. I think you need to really on the race, otherwise you'll not beat the platinum membership. So if you're new to this slide, basically every minute you attend, you'll get every 1 point, right? So if you attend more sessions, you'll get more points, and accordingly, you'll get this platinum membership and badge as well as certification of participation, all those benefits. And you can see we already see like a lot of people are in the gold, especially Farouk is actually leading the leaderboard. Congratulations, Farouk, and hopefully we want to see you in platinum maybe tomorrow, right? And for a bonus points, please send an email to ogyatra@aog.org with the screenshots of your Twitter tweeting, not just our screenshots, because it's so fun. We are receiving the screenshots of our screenshots. No, when you're tweeting or when you're posting in Facebook, we want to see that authentication, right? So send us that screenshots, not these screenshots. Anyway, we will send a detailed email if you don't understand. And know your speakers. This is very important. Thanks to Jim, Bob, and Javed, especially a big thanks to Jim Grisanzio. He's really doing a lot of work and interviewing a lot of speakers. And this is the only way you can get to know about speakers. So please watch those videos and continue our conversation in Twitter. And presentation material will be available. We are in the process of uploading. You'll see most of the materials in a couple of days. If you don't see, please hold for a couple of days because we are just volunteers. We are managing both our primary job as well as AIOG. So please hold, give us a couple of times. Don't send emails saying that I don't see that presentation, this presentation. Give us some time. Also, speaker feedback. If you like Christopher's and Avinash session, if you want to see more sessions, please provide the feedback and what you want to cover. That will be great. So with that, we have a master class coming. Let's have some effective rest. It's not normal rest, but so let's see you guys in half an hour's time. Yeah, half an hour, or I don't know, it's a lunchtime. Sorry. So the next session is from Mohammed Thaman. This is a second session from Thaman. Thank you. Thanks again, Avinash and Christopher, spending time with us. With that, I'm closing the session.